Let's see. All right. Starting. And we're live. All right. Welcome to Data Science Club, lucky number 13. Today we're going to be looking at playing games with reinforcement learning. Reinforcement learning is a technique where you kind of train your AI over time using a system of rewards and penalties to learn a behavior. This is the type of learning that has been used to teach algorithms to play chess and Go, and then more recently StarCraft or StarCraft 2, I guess. Anything else on reinforcement learning before we jump in?
No, just basically most of the algorithms for chess, they have beaten grandmasters, so they have gotten very good at it.
Yes. Yeah, I mean, so one of the neat things here is even though this is a really simple example we're going to show today, this is the exact same process that's used to learn how to play chess and for a computer algorithm, which is a much more complicated game. And the tool we're going to use actually has built-in hooks to play just about any type of game if you want to dive deeper into it and learn other things. On the practical science standpoint, there are ways that reinforcement learning has been used in more practical scientific applications. I'm going to see if I have. Yeah, so here's a paper right here, just as matter of context, in a journal called Kidney Diseases that talks about deep reinforcement learning in medicine. And if you come down to the bottom, it's kind of a survey paper, but they talk about using it for developing treatment strategies. Is one of the ways that reinforcement learning is used in medicine. So it's not just applicable to video games, but games is one of the places where it's a nice low-hanging fruit for seeing whether or not our algorithms are even working. So the tutorial that we're going to go over is on medium.com. We'll post this link to this article in the notes, but thankfully they actually have a GitHub of a Jupyter Notebook that actually they have several Jupyter Notebooks, but we're going to go over this cart pole game understanding one. All right, so first things first, we need to get this code in our directory. So we're going to use one of the jobs that we did on a previous session, and we're going to use this to copy it in. So we're going to come here, and let's see, where's my Jihad dashboard? All right, so this is the Open On Demand portal. If we come to Job Composer, all right, so we can create a new job from the default template, and then we're going to come down here and we're going to open up the job, and we're going to paste over this. And all right, so we're not building autoencoders in Keras today. Today we're doing reinforcement learning. And so this is the folder that it's going to clone this repository into, and then we need to put the actual link to the repository right here. So we'll grab that. All right, so it's this Tenkala AI examples. This is the author of the Medium article. And again, if you like this tutorial, she's got a few other that you can look at with corresponding more in-depth read-throughs on her Medium page. So we'll copy this GitHub link, and then we're going to put it right in here. Okay. All right, and then we're going to save that. And all right, so now we can see that that's in our main job. So then if I submit this, it should just work. So it says that it's running, and it shouldn't take long. We can look at all right, so it says it's completed. We're going to look at our log file. All right, so it was cloning it. So we can feel pretty good that it's probably there. Now, the other thing that I noticed when I was looking at this code before we started is that it's using a library called Gym. So Gym is from this company called OpenAI. And OpenAI, they're trying to build open source tools for doing reinforcement learning tasks. And this Gym library is their library that they've created. So you can see they have all sorts of things like walking ants. This cart pull game is the one that we're going to do today. Let's see, pendulum. I kind of like these Atari games. So maybe at some point we'll have to do an Atari game because I think that would be fun.
So in this examples context, this gem library, they provide the state of the game to the computer. So like when we are playing the game, so if we are playing this card pull game, we'll have our eyes to visualize the screen, and we'll see that, oh, this is moving in this side, so we need to move the base to the other side so that it doesn't fall off.
Yeah.
And that's the state that this AI would be giving to the computer, because computer cannot actually see this thing. It needs to know the state of the game at any particular time. So
yeah. So or another way of saying it is you always have to have some metric of whether or not you're playing the game well.
Yeah.
And so this Gym gives coding hooks into the video game so that we can pull out that state or those metrics as to whether or not we're winning or losing and how many points we're getting and all that kind of stuff.
Yeah, and I've never worked with this library before, but at least according to the author, card pull is like the hello world of the gym library.
Yeah. Yeah, I think it's one of the easiest ones to pull in, but we will find out. So what we're going to do, all right, so the very first, the number one data science club that we did, we created a Anaconda environment, and that should still be in your environment if you've been following along. So what we're going to do is we're just going to add this Gym library to our Anaconda environment before we move on. So we're going to do a little bit of command line stuff. Let me make this not full screen because I think that might be difficult. All right, here we go. All right, so now we're right here in the middle. All right, so what we're going to do is we need to first, let's see, do we need to open up a compute node, or is this probably lightweight enough we can just do it?
I'm not really sure about this. We can open up a compute node.
Yeah, let's open up a compute node. So if you just Google UAB, Chiha, Slurm, then our Wikipedia page should show up on Slurm. If we get inside that page, we can scroll down, and what we want is an interactive job. So we're going to keep on looking. These are batch job scripts. All right, so we don't really care too much about what's going on in the job. So we can just grab this default one presented here, and we can paste it in. And let's see, if that takes a while, we'll limit the resources. Okay, so that didn't take too long. All right, so if you're reading this in depth, srun is the command that says, hey, scheduler on the supercomputer, I'd like some resources, and then the rest of these arguments indicate what types of resources we'd like. So we've requested this compute node for 8 hours with 16 gigs of RAM because we're asking 4 CPUs and 4 gigs per CPU. And so this is good social behavior on a supercompute cluster, is to request your resources before you start using them, because otherwise it would be like if you were working on your laptop and you got up away from your desk and I decided, hey, he's not using his computer, so I'll just get on there and start up my analysis. And then when you get back, your computer's frozen because I'm running some heavy thing. So it's just good behavior. This way, we're all using separate resources and everybody can play nicely together. So now let's see, we've got to load our Anaconda environment, right?
Yeah.
So we'll go module load Anaconda 3. I think we have a few different versions on here. All right, so 5.3 is the latest, so we'll go 5.3. All right. And then we're going to activate our environment from the first week. So it's source activate, and then it's NBOTW for notebook of the week. All right. And then in this instance, the instruction said to do pip install gem. So we're going to do that. And so this is going to install that gem library into our notebook of the week environment, so that then when we, so now when we open up that Jupyter notebook to access this, it will pop up in there, and we shouldn't have any problems with the libraries. All right. So now we got to go back to our dashboard and interactive apps, Jupyter notebooks. And let's see. So we're going to, we really just need 1 hour, should be fine. 4 CPUs, 4 gigs of RAM. We're going to use the Pascal nodes because we are using TensorFlow and Keras, and so hopefully it'll still use our GPU there. And then we're going to make sure that we specify our notebook directory to data user, your Blazor ID, and then RC-DSC, because I believe we cloned the repository into a subfolder of that. So we go launch. And let's see how this works. All right, so it's already starting, which is nice. All right, so now we can connect. And all right, our repository we cloned is right here. And we're going to look at this cart pole game understanding. All right. So we've got the code from the repository here. And so now we're going to start just kind of going through it. It's not very long. You can see most of the length here is just the output of everything. But by the end of this, we'll have created a artificial intelligent agent that can play this cart pole game. So first things first, we need to import our libraries. So we're going to import this gem library as the new one that we just installed. And then Keras is a high-level interface to TensorFlow and some other machine learning libraries. So that way we'll be able to build our machine learning model that will learn how to play the game. All right, so we'll run that. No module named gem. Oh.
Arvind,
I don't think we're in the right environment.
Yeah.
All right, so if this happens to you, let's see, I think we go up to kernel, and we're gonna change kernel. So I think right now we're just in Python 3, but we're gonna change to Notebook of the Week. All right, and so now you can see up here it says Conda ENV Notebook of the Week. And now if we go this again, it should, quotey fingers, it should load up just fine.
Yeah, I think it has already gone through the gym
I think
import
so.
part. So
Yeah, so right now our Keras seems to be using TensorFlow for the backend, which is the Google machine learning library. And so now we can keep on going. All right, so this next piece here is to instantiate the environment. So there are a bunch of different arguments that you could put in here. Here we're going to do cartpole v1, and that will create that that game that we saw. Let's see if we can have, oh, that's the wrong one. There you go. So if we look on here, all right, so this is what we're instantiating. And so let's go back to our code. All right. So this is resetting the environment, so making sure there aren't any weird initialization things going on. And then setting up just the variables for that environment is what it looks like.
yeah, most of these variables are for the game. So
Yeah.
it looks like it needs to take 500 steps, and the final score should be 60 for
Yeah.
this game to be considered a success. So.
Okay. Yeah. So this function here, so this is how you define a function in Python. So def, some name, and then a colon at the end. So this is just to play some random version of the game. Now, if you're doing this on Chiha, we don't have a screen session attached to this Jupyter Notebook. So while Jupyter Notebooks will render like a picture, this is creating a video, and the rendering mechanism that they have built in for this doesn't work super great with the Jupyter Notebooks that's on Chiha. If you're running this on your local machine, this will absolutely work. I tested it on my local laptop, and I was able to see the little cart pole thing moving around. And so if you want to give that a try, come into office hours and we'll be happy to help you set up your environment on your local machine so you can see how it's working. But we can still see the metrics that spit out of this. So we'll create that function, and then now we're going to play the random game first. All right. So yeah, so at each step, so these observations are all of the metrics that are accessible to use to manipulate the game and to understand what's going on. Okay, so we'll keep on going. How many steps would he do? All right, so we did about 17 steps here. All right, so now we're going to do the model data preparation. All right, so this is another function. So we start out with no training data, and basically what's going to go on here is we are going to have the computer play a lot of games. So initial games is the variable that we defined up here. So we're going to have our AI play 10,000 games. And then what's going to happen is we're going to reward the games that have a higher score. And all right, and if the scores are above 60, which was our score requirement, then we're going to keep those in our memory. Okay. Okay. Seems straightforward enough. All right, so there's no output here because that's just creating the function. But then we're going to do this model data preparation and see what pops out. All right, so that just played 10,000 versions of this cart pull game. And so we can start to see some positive behaviors, some negative behaviors, and have something to base our training off of for our model. All right, so this, like we've mentioned before, most of the exciting stuff in terms of the machine learning aspects of what we're doing happen in just a few lines of code. So this is the entire machine learning model that's used. So this sequential is a keras command saying, I'm just going to build a straightforward model that's just layer on top of layer on top of layer. And then each line after that is the layers that we're adding. So this is just a 3-layer densely connected neural network. So this is not considered deep learning by any stretch of the imagination. This is 2 layers and an output. And so we've got a densely connected layer that has 128 nodes. The next one has 52 nodes. And then the next is the output size, which we'll see exactly what that is. But I believe the output size is what the command should be given us a situation. Mm-hmm. And then the loss that's going to be used, MSE stands for mean squared error. And then, so after you've added your layers, you have to compile, and then this function is going to return the model. All right, so again, no output because that's just a function. And now we're going to create a function to train our model. And so this creates an X and Y. So X is going to be the input metrics, and Y is going to be the result that we're looking for. And so what we're going to do here is we're going to build the model. X and Y are both from our training data that we created earlier. All right.
Is there a particular reason for using model variable in both build model and train model? I thought you could have.
Oh, okay. So yeah, it's just a little bit messy in how they wrote the names. So this could be named anything, right? So we could call this Bob inside of here. And that's not going to mess with anything. Because this is just the name that we've given to our machine learning model.
Yeah, I mean, there would have been some distinction because now it's like, oh, both of them are returning model.
Yeah, so both of them are returning model, which is confusing, but essentially we're using a function to call a function.
Yeah.
The inner function returns a model, and then the outer function returns a fitted model. Because here what we're doing is we're taking the model from build model. So here it builds the model, and then here after the model is built, then we fit it very similarly to how we fit the scikit-learn, logistic regression kind of stuff.
And we're only running it for 10 epochs.
And we're only running it for 10 epochs. An epoch is an entire view of your training data. So there's lots of different types of iterations in machine learning. There's iterating over a batch. There's iterating how many times you iterate inside of an epoch, and then there's epochs. Epochs is just, it's the shorthand for saying after I've seen all of my data once, then that's an epoch. All right. So now we're going to train our model by calling that function. And all right, so epoch 1. This should go pretty quick because we are using the GPUs. All right, so our loss went from 0.25 roughly to 0.23, so we got better. And then let's see what's going on here. So now we're going to play another 100 games is what it looks like. But now, instead of just choosing a random action, we're going to use our model right here in the middle. So trained model.predict will take in whatever the last state is of the cart pole and then predict what the action should be. And then this will actually give us a probability of what the right action is for each action. And so what argmax does here is actually say, okay, give me the most likely action that I should take.
Yeah, and so the action over here, I believe, has two values, 0 and 1. And I think 0 means moving the base of the game to the
Left.
and the 1 means right.
Oh, okay.
So
yeah, that makes sense, because if you were to play this game in a browser or something, you would just use 2 arrow keys. You would only have 2 inputs.
yeah. So this is what it's doing. It's just asking. So if for the first time it asks it to run a random
Yeah, just to
random step,
initialize.
yeah. And after that it asks to use the model that we have built right now. It asks to base your next move based on the prediction from the model.
Okay. Yeah. No, that's good. And so yeah, so then we're gonna do our action, and then we're gonna see what our score looks like after that, and then at the end of each game, we're gonna append our score to the score list, and then we'll print out what our scores ended up being.
So remember, we did this earlier as well when we weren't creating any, when we didn't have any deep neural network.
Yeah, so that was up here when we played 10,000 games.
Yeah, so this is the average score that we got. So these are the scores that we got over here when we were just playing it, I don't know, randomly or?
Yeah, I believe it was randomly, and after playing it randomly, you can see we got some scores that were above 100, but most of them were a lot lower. And given that we played this 10,000 times and we only had, a few hundred instances of success.
And like you saw earlier when we were defining the variables, having a score of 60 is success. So all the scores that you'll see over here
are greater than 60, but we did this 10,000 times. It looks like there's less than 1,000 numbers there, so probably only 1% of the time or so did we actually make it above there with just random choices. Now we're using our model, and if we run that, all right, so it's thinking, and we've got to wait for a minute here. So yeah, so it's printing. All right, so here we go. So we went from an average score of like less than 100 to an average score of almost 400.
Yeah. And it also shows us how many times we moved to the left and how many times we moved to the right.
Yeah.
That reminds me of that old song. To the left.
Oh yeah. To the left, to the left, to the left, to the right. So this, and again, if you were on your local machine, you could actually uncomment this render command and visually see the computer playing the game. In this instance, we wanted to be able to do it on Chiha with the nice GPUs, and so we kind of just are leaving some of it to faith that it's actually playing the game. But again, I did test it out, and you do actually see the cart pull if you're running it on your local machine. And we may be able to, if you come into office hours, we can always hack away at it. We might be able to get it working in the desktop or something like that. But let's take a look. So if we go down to the bottom of the article, then she's posted a functional version here. Yeah. And so that's hopefully what it'll look like after you've done your training.
Yeah, and I mean, like you guys saw, the number of times it moves to the right or the left were very similar. It was almost 50%, and that's how it should be. Like, I mean, you're just sensing the slightest tilt in the stick or pole, and you're moving your card to counteract that tilt.
Mm-hmm. So yeah, next week we probably won't be around because we're going to be at a conference. So we'll miss you guys next week, but we'll be back on course the first week of August with something else fun. And we've been talking to MathWorks about doing some MATLAB examples, so those should be coming hopefully in August. But in the meantime, come to office hours, and we'd be happy to help you out with any of these things. And if you have any examples or things you'd like us to talk about, we're happy to do that. Just let us know in the comments or via email or something like that. So yeah, anything else?
No, that is it. We'll see you guys next week.
Yeah, sounds good.